So I want to take the derivative of this. So let's first see what's the outside. Well, the outside is something cubed. Inside of that is x squared over 5 minus x. So the outside, that's an easy derivative, but the inside is going to need a quotient rule. So let's take the derivative of the outside, because this is a chain rule, and that would be 3 blank squared. And we chain rule, we leave the inside, so what's left in the inside is simply this, what we started with, x squared over 5 minus x. But now we must take the derivative of what's in the inside, and this right here is a quotient rule. So we have a quotient rule to deal with here. The bottom's going to be 5 minus x all squared. The top is going to be something times something minus something times something. Because you got a quotient rule of the blue part. So you take the derivative of x squared, that's 2x. You leave the 5 minus x. You leave the x squared and take the derivative of 5 minus x, and that is negative 1. Now, that is the derivative. But you need to clean it up. And here's where it gets a little bit messy. So here we go. Let us clean this up one step at a time. Actually, do it really quick, one big group. We leave the 3, we get an x to the 4th, and we do a 5 minus x squared. Now you might be like, how'd you do that? Well, can't you square both of these? And won't the top one go to the top with the 3, and the bottom one just stay on the bottom? Now here, can we bring this and put it on the bottom with it? So can we also bring the next 5 minus x squared over? So this stays with this guy. Remember, he got squared. Now can we clean up this? Can we clean up this mess? To clean up that mess, aren't you going to distribute? So won't that be 10x minus 2x squared? And then when you multiply the next piece, won't that be plus x squared? A negative times a negative is a plus x squared. So let's do a little bit more simplification here. We still have the 3x to the 4th on top. These two combine, so won't that be 10x minus x squared? And on the bottom, won't that be 5 minus x to the 4th? And I'm going to stop there. I mean, yes, you could pull a GCF out of these two, but I'm going to stop here. That looks clean enough for me. So if I want to take the derivative of this right here, you should see I have to take the derivative of this, and then, oh no, this whole thing's the inside. So we're going to take the derivative of this is the inside, and the 4 is the outside, the 4th power. So what you should see here is you have something to the 4th power, that's the outside, and all of this is the inside. So to start this, I'm going to take the derivative of the outside. There's the outside done. I leave the inside. Oops, this is sine x to the 1/2. I'm putting x to the 1/2 because that will help later on. Now, by the way, if you know anything about log properties, could you technically take that 3 and put it out front? That's interesting. Logs have interesting properties. You could save yourself some time by taking that 3 and putting it out front. Logs do have that ability. So now we got to take the derivative of the inside. So I got to take the derivative of this green part. So we're going to take the derivative of that. So when I take a derivative of the first piece here, isn't that going to be another chain rule? Isn't that going to be the derivative of sine, the outside, is going to be cosine, leave the inside, but then we have to take the derivative of the inside now. Then we also have to take the derivative of this right here, so that would be 1/2 x to the negative 1/2. Okay, so next we need to take the derivative of this next piece, but this next piece is another chain rule. So I put plus, derivative of log is going to be 1 over, okay, leave the log x to the 3rd, but we also have an ln 10, because remember log is base 10. There is a base 10 here, hiding, so we need the ln 10 down there. All right, and then we take the derivative of the inside, x to the 3rd. Now you normally put it behind, but I'm just going to put it on top because you can. So the derivative of x to the 3rd is 3x squared. All right, so that would be my derivative. Big, ugly, huge mess. Let me try to clean it up maybe a little bit. I'm just going to clean it up a little bit. So what we would have here, let's see. I'm going to say, I'm not going to pull out x's. I'm just going to leave the 4. I'm going to leave this one and put sine square root x plus log x. I'm going to put a 3 there just to practice. Again, like I said earlier, you can take the powers and bring them up front. I'm just doing that because, just to show you can. And then let's clean this up. Again, we don't want to get common denominators. I'm just going to put, again, cosine square root of x. I'm going to put that over 2 square root x. Okay, because you can, this thing is all in the denominator. The 2 goes to the bottom, the square root of x goes to the bottom, so I can write like that. All right, and the last piece, I'd have my plus. I put the 3x squared on top, and I have the 3 log x times, I want to say the plus, ln 10. And that would be the derivative of this as multiple chain rules involved.